Welcome to Click for IB Biology. We're studying the niche theory on the course, and here we're looking at harvesting of light, which of course is photosynthesis, and the competition in order to actually find that light. There's a blank version of this presentation listed in the description. You can download that and annotate that with your own notes, and then when you've made your own notes, you can take the 10-question quiz. The answers are there so that you can evaluate your learning and understanding of this topic. So to illustrate the competition of light, I'm largely focusing on forests, and in this particular case, the forests of Southeast Asia, the ones with which I'm familiar and which I lead field trips. And the first thing that we want to talk about with the competition and the harvesting of light is the formation of the canopy. So the forest canopy is seen here, and the greenness of the canopy and the ways in which the tree canopies merge with each other, creating this light harvesting area of chlorophyll in which the light energy is absorbed and turned into chemical energy. And then the way in which the same canopy that we can see here is taking in the carbon dioxide to fix that using the enzyme ribisco to create organic compounds. And so we have this almost like when looking down on the canopy, this sea of ribulose, bisphosphate, carboxylase, the enzyme, fixing the carbon dioxide but driven by the trapping of light energy. And that's what happens in this canopy area here in the forest. However, there's always some species that attempt to improve their competition for that light by growing up and above the canopy like this, and we call these emergent species. And so they stick their head out above the normal canopy in an attempt to outcompete the trees at this level here in the normal canopy. However, such a strategy takes them into being exposed to high winds and rainfall, and the consequence of that is a risk of damage. So this is a gains benefit that the plant has to make in doing so. And whilst the trees are harvesting light in the upper layers with their chlorophylls and the canopy, down beneath on the forest floor, there's an abundance of species down here working in the shade areas, and they have their adaptations to catching light as well. And typically what we see are very large leaves with very dark concentrations of chlorophyll in those leaves. The canopy above tends to be formed from smaller leaves, and the chlorophylls that operate there tend to be associated with very intense light. But on the forest floor, things like plants such as gingers are down there in the shade, and they have very large leaves for the capturing of any available light. And there's also adaptations within the palisade layer of their leaves as well to maximizing that yield. Now, another strategy for obtaining light in the forest is not to compete as a tree, but instead to actually grow upon a tree. And this is what we call an epiphyte. So these bromeliads that we can see here are often joined by bromeliads and ferns and various other plants are able to grow on the trunks of tropical trees, and they establish a very simple root system to begin with, and harvest the light, but also attempt to obtain organic nitrates through simple root systems on the trees. These are usually not parasitic, but epi on the outside of other plants, epiphytes. Now, another strategy for getting to the light is demonstrated by the strangler plants, and in particular the strangler figs are famous for their strategy, where their seeds are dropped into the canopy of a host tree that we can see here. That's in black, and then in green are the germinating seeds of the fig tree, and these are growing down some root systems downwards, but they are also already photosynthesizing up in the canopy. So it's using the host tree to do all the lifting from the forest floor. Within the development of the Strangler, what happens is that these root systems, these stems, extend downwards and they begin to coil around the trunk of the main tree here, like this. And then over time, they begin to constrain and constrict the phloem in the outer section of the host tree, so that in the end, with maturity, the fig ends up becoming the dominant plant, and the host plant may indeed actually fully die away. And so in the sketch here that we made on one of our field trips, you can see the fig strangling the host tree, which is just barely still visible on the inside. Now, in contrast to the stranglers where they're growing downward, there are the lianas, which germinate on the forest floor, and what they will do is to grow around. These are climbers. They grow around the stem of the tree like this, and they will climb their way up to the canopy like so, where they will then put their leaves out for photosynthesis, but having this very, very long stem curling around, using the host tree as seen here for support, so it doesn't waste energy on creating its own support in its own trunk. It uses the trunk of another species and climbs up into the canopy. So the lianas are growing upwards into the canopy, whereas the strangler figs begin in the canopy and work their way down. So here we have different methods and different strategies for grabbing the light in the competition for harvesting light in the forest. The next video link is showing on the left hand side there. A chance to subscribe to the channel, that would be appreciated, and my playlist for the niche videos in this part of the IB biology course are listed. Thank you for listening.